Let's discuss forces on solids. Let me first specify that all solids, no matter what they are going to be somewhat elastic. So when we mention talking of a force on a solid, we are talking of a force on an elastic object, elastic body. So when a force is applied to an elastic body, because it's elastic, that body is going to deform. The deformation depends on the type of force we apply to it. We talk of two types of forces. Compression forces, the ones that are going to push down on the object like this. So in this particular case, this is the force F. It's pushing down on it to compress it by an amount X. If the object had a height L initially, it's going to become L minus X, the new height, due to that compression force. A here is the cross-sectional area of the object. And the other type of force is a tensile force. It's the one when we talk about tension, tensile force. So it's the one that's going to make it more taut, pulling on it, like this force here. It pulled on this object here to make it longer by an amount X. We define as stress as the force per unit area upon which the force is going to act. For example, if we look here, we have a tensile force. It is acting on this area here, A, by pulling the object. And then this one here is a compression force that's pushing down on the object through the area A. Now, in both cases, it does not matter whether it is a tensile force or a compression force. The stress, see the symbol here, sigma, is defined as force over area, F over A. The unit of stress is Newton over meter squared, Newton for the force, meter squared for the area. We call newtons per meter squared Pascal. Symbol for it is capital PA, Pascal. Now, this is the same unit as what's used for pressure, and the expression actually is the same as the expression for pressure. What we define as strain is the deformation per unit length, per unit of the original length. For example, if I have an object like this, of length L, and through a tensile force, I pull it by an amount X, so the new length is L plus X. The strain is defined by X over L, L being the original length. Notice here, since strain is a length over a length, it has no units. Most materials do not stretch much, really, before they get damaged, before they break, essentially. So strain values are in the order of 10 to the minus 6. Even though strain does not have a unit, we usually say microstrain to specify that we are talking about strain.